In this lesson, you'll get to learn why you should fine-tune, what fine-tuning really even is, compare it to prompt engineering, and go through a lab where you get to compare a fine-tuned model to a non-fine-tuned model. Cool, let's get started. All right, so why should you fine-tune LLMs? Well, before we jump into why, let's talk about what fine-tuning really is. So what fine-tuning is taking these general purpose models like GPT-3 and specializing them into something like ChatGPT, the specific chat use case to make it chat well, or using GPT-4 and turning that into a specialized GitHub Copilot use case to autocomplete code. An analogy I like to make is a PCP, a primary care physician, is like your general purpose model. You go to your PCP every year for a general checkup. But a fine-tuned or specialized model is like a cardiologist or dermatologist, a doctor that has a specific specialty and can actually take care of your heart problems or skin problems in much more depth. So what fine-tuning actually does for your model is that it makes it possible for you to give it a lot more data than what fits into the prompt, so that your model can learn from that data rather than just get access to it. And from that learning process, it's able to upgrade itself from that PCP into something more specialized, like a dermatologist. So you can see in this figure, you might have some symptoms that you input into the model, like skin irritation, redness, itching, and the base model, which is the general purpose model, might just say this is probably acne. A model that is fine-tuned on dermatology data, however, might take in the same symptoms and be able to give you a much clearer, more specific diagnosis. In addition to learning new information, fine-tuning can also help steer the model to more consistent outputs or more consistent behavior. For example, you can see the base model here. When you ask it, what's your first name? It might respond with, what's your last name? Because it's seen so much survey data out there of different questions. So it doesn't even know that it's supposed to answer that question. But a fine-tuned model, by contrast, when you ask it, what's your first name, would be able to respond clearly, my first name is Sharon. This bot was probably trained on me. In addition to steering the model to more consistent outputs or behavior, fine-tuning can help the model reduce hallucinations, which is a common problem where the model makes stuff up. Maybe it will say, my first name is Bob, when this was trained on my data, and my name is definitely not Bob. Overall, fine-tuning enables you to customize the model to a specific use case. And the fine-tuning process, which we'll go into far more detail later, is actually very similar to the model's earlier training recipe. So now to compare it with something that you're probably a little bit more familiar with, which is prompt engineering. This is something that you've already been doing for a while with large language models, but maybe even for over the past decade with Google, which is just putting a query in, editing the query to change the results that you see. So there are a lot of pros to prompting. One is that you really don't need any data to get started. You can just start chatting with the model. There's a smaller upfront cost, so you don't really need to think about cost since every single time you ping the model, it's not that expensive. And you don't really need technical knowledge to get started. You just need to know how to send a text message. What's cool is that there are now methods you can use, such as retrieval augmented generation, or RAG, to connect more of your data to it to selectively choose what kind of data goes into the prompt. Now, of course, if you have more than a little bit of data, then it might not fit into the prompt, so you can't use that much data. Oftentimes, when you do try to fit in a ton of data, unfortunately, it will forget a lot of that data. There are issues with hallucination, which is when the model does make stuff up, and it's hard to correct that incorrect information that it's already learned. So while using retrieval augmented generation can be great to connect your data, it will also often miss the right data, get the incorrect data, and cause the model to output the wrong thing. Fine-tuning is kind of the opposite of prompting, so you can actually fit in almost an unlimited amount of data, which is nice, because the model gets to learn new information on that data. As a result, you can correct that incorrect information that it may have learned before, or even put in recent information that it hadn't learned about previously. There's less cost afterwards if you do fine-tune a smaller model, and this is particularly relevant if you expect to hit the model a lot of times, so have a lot of either throughput or you expect it to just handle a larger load. And also, retrieval augmented generation can be used here too. I think sometimes people think it's a separate thing, but actually you can use it for both cases. So you can actually connect it with far more data as well, even after it's learned all this information. There are cons, however. You need more data, and that data has to be higher quality to get started. There is an upfront compute cost as well, so it's not free necessarily. It's not just a couple dollars just to get started. Of course, there are now free tools out there to get started, but there is compute involved in making this happen, far more than just prompting. And oftentimes you need some technical knowledge to get the data in the right place. And that's especially, surrounding this data piece. And, there are more and more tools now that's making this far easier. But you still need some understanding of that data. And you don't have to be just anyone who can send a text message necessarily. So finally, what that means is for prompting, that's great for generic use cases. It's great for different side projects and prototypes. It's great to just get started really, really fast. Meanwhile, fine-tuning is great for more enterprise or domain-specific use cases and for production usage. And we'll also talk about how it's useful for privacy in this next section, which is the benefits of fine-tuning your own LLM. So if you have your own LLM that you fine-tuned, one benefit you get is around performance. So this can stop the LLM from making stuff up, especially around your domain. It can have far more expertise in that domain. It can be far more consistent. So sometimes these models will just produce, something really great today, but then tomorrow you hit it and it isn't consistent anymore. It's not giving you that great output anymore. And so this is one way to actually make it far more consistent and reliable. And you can also have it be better at moderating. If you've played a lot with ChatGPT, you might have seen ChatGPT say, I'm sorry, I can't respond to that. And you can actually get it to say the same thing or something different that's related to your company or use case to help the person chatting with it stay on track. And again, so now I want to touch on privacy. When you fine-tune your own LLM, this can happen in your VPC or on-premise. This prevents data leakage and data breaches that might happen on off-the-shelf third-party solutions. And so this is one way to keep that data safe that you've been collecting for a while. That might be the last few days. It might be the last couple decades as well. Another reason you might want to fine-tune your own LLM is around cost. So one is just cost transparency. Maybe you have a lot of people using your model and you actually want to lower the cost per request. Then fine-tuning a smaller LLM can actually help you do that. And overall, you have greater control over cost and a couple other factors as well. That includes uptime and also latency. You can greatly reduce the latency. For certain applications like autocomplete, you might need latency that is sub 200 milliseconds so that it is not perceivable by the person doing autocomplete. You probably don't want autocomplete to happen across 30 seconds, which is currently the case with running GPT-4 sometimes. And finally, in moderation, we talked about that a little bit here already, but basically if you want the model to say I'm sorry to certain things or to say I don't know to certain things or even to have a custom response, this is one way to actually provide those guardrails to the model. And what's really cool is you actually get to see an example of that in the notebooks. All right, so across all of these different labs, you'll be using a lot of different technologies to fine-tune. So there are 3 Python libraries. One is PyTorch, developed by Meta. This is the lowest level interface that you'll see. And then there's a great library by Hugging Face on top of PyTorch and a lot of the great work that's been done. And it's much higher level. You can import data sets and train models very easily. And then finally, you'll see the Llama library, which I've been developing with my team. And we call it the Llama library for all the great llamas out there. And this is an even higher level interface where you can train models with just 3 lines of code. All right, so let's hop over to the notebooks and see some fine-tuned models in action. Okay, so we're going to compare a fine-tuned model with a non-fine-tuned model. So first we're importing from the Llama library, again this is from Llama, the basic model runner. And all this class does is it helps us run open source models. So these are hosted open source models on GPUs to run them really efficiently. And the first model you can run here is the Llama 2 model, which is very popular right now. And this one is not fine-tuned. So we're going to just instantiate it based on this is its Hugging Face name. And we're going to say, tell me how to train my dog to sit. So it's just, really, really simple here into the non-fine-tuned model. We're going to get the output out, and let's print non-tuned output and see. Oof, okay, so we asked it, tell me how to train my dog to sit. It said period, and then tell me how to train my dog to stay, tell me how to teach my dog to come, tell me how to get my dog to heel. So clearly this is very similar to the what's your first name, what's your last name answer. This model has not been told or trained to actually respond to that command. So maybe a bit of a disaster, but let's keep looking. So maybe we can ask it, what do you think of Mars? So now, at least it's responding to the question, but it's not great responses. I think it's a great planet. I think it's a good planet. I think it'll be a great planet, so it keeps going. Very philosophical, potentially even existential if you keep reading. All right. What about something like a Google search query, like Taylor Swift's best friend? Let's see what that actually says. All right, well, it doesn't quite get Taylor Swift's best friend, but it did say that it's a huge Taylor Swift fan. All right, let's keep exploring maybe something that's a conversation to see if it can do turns in a conversation like ChatGPT. So this is agent for an Amazon delivery order. Okay, so at least it's doing the different customer agent turns here, but it isn't quite getting anything out of it. This is not something usable for any kind of like fake turns or help with making an auto agent. All right, so you've seen enough of that. Let's actually compare this to Llama 2 that has been fine-tuned to actually chat. So I'm going to instantiate the fine-tuned model. Notice that this name, all that's different is this chat here. And then I'm going to let this fine-tuned model do the same thing. So tell me how to train my dog to sit. I'm going to print that. Okay, very interesting. So you can immediately tell a difference. So tell me how to train my dog to sit. It's still trying to autocomplete that. So tell me how to train my dog to sit on command. But then it actually goes through almost a step-by-step guide of what to do to train my dog to sit. Cool. So that's much, much better. And the way to actually quote unquote get rid of this extra autocomplete thing is actually to inform the model that you want instructions. So I'm actually putting these instruction tags here. This was used for Llama 2. You can use something different when you fine-tune your own model, but this helps with telling the model, hey, these are my instructions and these are the boundaries. I'm done with giving this instruction. Stop continuing to give me an instruction. So here you can see that it doesn't autocomplete that on command thing. And just to compare, just to be fair, we can see what the non-fine-tuned model actually says. Great, it just repeats the same thing or something very similar. So not quite right. Cool, let's keep going down. So what do you think of Mars, this model? Oh, it's a fascinating planet that has captured the imagination of humans for centuries. Okay, cool. So something that's much better output here. What about Taylor Swift's best friend? Let's see how this does. Okay, this one's pretty cute. It has a few candidates for who Taylor Swift's best friend actually is. Let's take a look at these turns from the Amazon delivery agent. Okay. Says, I see, can you provide me with your order number? This is much, much better. It's interesting because down here it also summarizes what's going on, which may or may not be something that you would want, and that would be something you can fine-tune away. And now I'm curious what ChatGPT would say for tell me how to train my dog to sit. Okay, so it gives different steps as well. Great. All right, feel free to use ChatGPT or any other model to see what else they can each do and compare the results. But it's pretty clear, I think, that the ones that have been fine-tuned, including ChatGPT and this Llama 2 chat LLM, they're clearly better than the one that was not fine-tuned. Now, in the next lesson, we're going to see where fine-tuning fits in the whole training process. So you'll get to see the first step in how to even get here with this fine-tuned model.